Welcome, class. Probability is a crucial part of competitive Pokemon. It's important in battle when trying to maximize your chances to get lucky or minimize your chances to get unlucky. It's also important in the team builder when deciding which moves to run and how many EVs to invest to reach a certain damage roll. It's also very important for post-game analysis, so you can complain about how unlucky you got down to the precise decimal place. In this video, I'm going to review basic concepts in statistics and probability and explain how they apply to competitive Pokemon. I'll be using the Scarlet and Violet Overused tier, a Smogon singles format for examples, but the rules of probability I'll go over apply to every aspect of Pokemon and even beyond. Understanding basic probability just makes you better at life. For background footage, it seemed thematically appropriate to use a paralysis spam team, so I hope you enjoy that. My opponents certainly didn't. Also, before we get into it, I'll be using words like probability, odds, and chance interchangeably in this video, and for our purposes, they all mean the same thing. Also, we're going to be getting into some numbers that have a lot of decimal places, so I'll be giving approximate numbers sometimes. I used exact numbers for all the calculations and only rounded numbers after all the relevant calculations were done to save time speaking and save space on the screen. Now, the easiest way to learn probability is through examples, so I'll start with a question. Scald is an 80 base power move with a 30% chance to burn. Assuming you hit both times and the Pokemon in question is not immune to being burned, what are the odds that a Pokemon avoids the Scald burn twice in a row? Before I tell you the answer, let's review some concepts briefly. The first concept to understand is that every probability is between 0 and 1, or 0 and 100%. Despite what your friend may have said about there being a 1000% chance they'd attend your party, there is no such thing as a 1000% chance, as I'm sure you found out when they weren't there. The chance of avoiding a Scald burn the first time is 70%. But this trend of subtracting 30 does not continue. The odds of avoiding a burn twice is not 40%. Think, if this trend continued, the odds of avoiding a burn 4 times would be negative 20%. This isn't real and means nothing. It can't be more than impossible to avoid a Scald burn 4 times. It's pretty lucky, but it's definitely possible. If you're ever calculating probability and you get a number above 1 or below 0, you're wrong. The next important concept to know is that the probability of an event not occurring is equal to 1 minus the probability of that event occurring. To give an example, imagine Focus Blast. Focus Blast has a 70% chance to hit, or 0.7, if we're using the normal convention, which we will do throughout this video. The odds then of Focus Blast missing or not hitting are just 1 minus 0.7, which is 0.3 or 30%. Lastly, the probability of A and B occurring is equal to the probability of A multiplied by the probability of B, as long as these events are independent, meaning the outcome of one won't impact the outcome of the other. Let's use Cinderace as an example here. What are the odds of Cinderace hitting a Focus Blast and then hitting a Pyro Ball? First, we've got to check for independence. Does Cinderace hitting or missing Pyro Ball impact the odds of hitting or missing Focus Blast, or vice versa? Even though it may feel like it, no, it doesn't. So, these events are independent. Pyro Ball has a 90% chance to hit, and Focus Blast has a 70% chance to hit, so the odds of hitting both are 0.7 times 0.9, which is 0.63 or 63%. Now, with all of these concepts down, we can answer the question about dodging the Scald burn twice. The odds of getting burned by Scald are 30%, so the odds of not getting burned by Scald are 70%. And the original question was, what are the odds that a Pokemon avoids the Scald burn twice in a row? If the odds of not getting burned by Scald once is 70% or 0.7, the odds of not getting burned twice is 0.7 times 0.7, which is 0.49 or 49%. Meaning, if you get hit with Scald twice, it's more likely than not that you'll get burned. This is also the exact same probability of hitting 2 focus blasts, 0.7 times 0.7. That means if you use 2 focus blasts and hit them both, you got lucky. There's a 51% chance you'll miss at least one, and only a 49% chance you'll hit them both. That's why I do my absolute best to avoid using focus blast. Now let's do a slightly more challenging example using the same concepts. How many freeze dries does a Curum have to use until it's more likely than not you'll be frozen? Essentially what we're looking for here is how many freeze dries it takes for the freeze chance to exceed 50%, or 0.5. And for the sake of simplicity, let's assume the opponent won't immediately unfreeze. The odds of freeze dry getting a freeze is 10%, so the odds of not being frozen are 90%. The odds of not getting frozen after being hit twice in a row is 0.9 times 0.9, which is 0.81 or 81%. We can keep multiplying by 0.9 until finally at 0.9 to the power of 7, we get approximately 0.478. In other words, if Curum uses freeze dry 7 times, the odds of not being frozen are 47.8%. Meaning the odds of being frozen are 1 minus 0.478, which is 0.522, or 52.2%. The correct answer then is 7 freeze dries. Another common application of these calculations is how long it takes for a defensive setup sweeper to be hit with a critical hit. The odds of a critical hit are 1 in 24, assuming the move doesn't have an increased crit chance. Suppose you're using a Rest plus Chesto Berry Zamazenta. You have Iron Defense, Rest, Crunch, and Body Press, and your Chesto Berry was used earlier in the game. You thought you were in a great spot as you clicked Rest on the opposing Landorus, but to your dismay, it turned out to be an Adamant, Terra Ground, Max Attack, Choice Band Landorus clicking Earthquake. The Landorus is dealing between 26 and 30% health to your Zamazenta every turn, meaning you can theoretically stall the Landorus out with Rest. You consider just attacking the Landorus, but you know the Choice Scarf Darkrai in the back will kill you with a Sludge Bomb if you do. Your only option is to PP stall all 16 Earthquakes and hope it doesn't get a critical hit, which will one-hit KO you instantly. What are your odds of successfully PP stalling Landorus out of all 16 Earthquakes? If you like, you can try and pause the video and figure it out for yourself. Now, the odds of a critical hit are 1 in 24, which is approximately 0.0417 or 4.17%. The odds of not getting critical hit are then 1 minus 0.0417, which is 0.958 or 95.8%. The odds of not getting critical hit twice are 0.958 squared, and not getting critical hit 3 times is 0.958 cubed. So, the odds of not getting critical hit 16 times in a row is 0.958 to the power of 16, which is 0.506 or 50.6%, meaning the odds are slightly in your favor to win and successfully PP stall the Landorus. For those of you that are wondering, the 17th attack is the point at which it's more likely than not that you'll have gotten a critical hit. Another fun little probability fact in Pokemon is that the damage calculator doesn't factor in the odds of a critical hit. Suppose my max attack Great Tusk is against a Clefable at 49% health, with max defense and HP investment. The calculator tells me that my odds to kill with a Headlong Rush are 37.5%. But this isn't considering the odds of a critical hit. The odds that Clefable does not die are thus equal to 1 minus 0.375 multiplied by 1 minus 0.0417, which gives us 0.599 or 59.9%. 1 minus 0.599 is 0.401 or 40.1%, so my odds of killing Clefable, with the critical hit factored in, are actually 40.1%, not 37.5%. It should also be noted that the calculator assumes Clefable is at exactly 49%. The showdown display always rounds up. 49% could really mean 48.1%. Clefable also might not really have maximum bulk and defense. Maybe there's a bit of special bulk in there too, or a few speed EVs. When you consider all of these factors, rolls are rarely as bad as they seem, and I'd say people should go for the roll more often than they do. Now let's talk about the team building side of things. But before we do, we must discuss the concept of expected values. The expected value of a random variable is equal to the mean, or average. Let's use Hydro Pump as an example. First, is it a random variable? When you use Hydro Pump, it usually has 110 base power, but sometimes has 0 base power because it misses. So yes, it has a degree of unpredictability and is therefore a random variable. Now, what is the average, or mean? Hydro Pump has an 80% chance to hit, meaning it is 110 base power 80% of the time and 0 base power 20% of the time. So we can calculate the expected value of Hydro Pump by multiplying 0.8 by 110 and then adding 0.2 multiplied by 0. This gives us 88, meaning the expected base power of Hydro Pump is 88. Surf, on the other hand, is 90 base power 100% of the time, so the expected base power of Surf is 90. Mathematically speaking, you could argue that this means Surf is better than Hydro Pump, but the reality is more nuanced. For example, if we look at Focus Blast, we see that 120 times 0.7, the accuracy of Focus Blast, is 84. Aurasphere is base 80 power, and so Focus Blast is theoretically superior. In practice, though, a ton of Pokemon that have Focus Blast would kill to have Aurasphere instead. Reliability counts for a lot, so a higher expected value doesn't necessarily make a move better. Deciding whether to run Surf or Hydro Pump and other moves should be done on a case-by-case basis. If you're running a Battle Bond Greninja with Terra Water on Rain, then Hydro Pump is probably overkill. It's not going to help you kill hardly anything that Surf didn't already kill. But if you're running a Battle Bond Greninja with Terra Ghost outside of Rain, maybe you need the power of Hydro Pump or you'll just be too weak. It's also worth mentioning that missing a move carries very different degrees of consequences for different Pokemon. Generally, bulkier Pokemon don't mind missing as much. If a Heatran misses a Magma Storm, it usually won't die for it. If a Deoxys Speed misses a Focus Blast, it's probably going down. Zap Cannon illustrates this point quite well. It's a 120 base power electric move with a 100% chance to paralyze if it hits, but only a 50% chance to hit. Deoxys Speed, a frail Pokemon that often relies on KOing Pokemon to avoid taking a hit, would never use Zap Cannon and would always prefer Thunderbolt. A bulkier Pokemon like Porygon 2 that can take a few hits and likes spreading status probably considers Zap Cannon worth the unreliability sometimes. The point is, expected value can give you an idea of whether a powerful, low-accuracy move is worth it or not, but what works best in practice should have the final say. Now, I have one more major concept I want to go over before this video ends: conditional probability. But first, let me introduce the example. You've got a max attack invested Cinderace with Blaze, and Pyro Ball, U-Turn, Sucker Punch, and Court Change, facing off against a 0 HP, 0 defense Tusk at 41% health. For the sake of the example, we'll assume the Tusk is at exactly 41.0% health. They're the last two Pokemon on the field, and Terra has already been used. The odds of Pyro Ball killing here, according to the calculator, is 62.5%. If Cinderace doesn't kill, it will die to Headlong Rush. So you have a 62.5% chance to win, right? As you could probably guess by now, not quite. There are a lot more factors to consider. There's the 10% chance of Pyroball missing, the 1 in 24 chance of Pyroball getting a critical hit. There's the 10% chance that Pyroball burns, meaning Headlong Rush wouldn't kill. But then there's also the 1 in 24 chance of a critical hit on Headlong Rush, which would allow Great Tusk to kill despite a burn. So, we learned earlier that we can multiply independent events to calculate probability. Does that mean we can multiply these? No, because they're not independent anymore. If Pyroball hits and gets a critical hit, can it also burn? No, the Tusk would be dead and therefore cannot be burned. Could Cinderace miss Pyroball and get a burn? Obviously not. So we need to consider conditional probability. The notation for this is as shown, the probability of event A given event B. For example, the probability of Headlong Rush killing, given Cinderace Pyroball misses, is 100%. In other words, if we assume Pyroball misses, then there is a 100% chance the Great Tusk will kill with Headlong Rush. The next important concept to understand is that the probability of A is equal to the sum of probabilities of A given B multiplied by the probabilities of B. The I subscript just tells us that there are many events B. Now, I know this is confusing, but don't worry, I'll break it down. In this case, event A is just Cinderace winning. And that sign that looks like a broken E without the middle line is just a summation sign, meaning we should add up all the probabilities of ways that Cinderace could win to find the total probability that Cinderace wins. So we need to consider all the ways that Cinderace could win in this exchange. If Cinderace misses, or as we should say, given Cinderace misses, there is a 0% chance that Cinderace wins. Headlong Rush will kill every time. This is not a way that Cinderace wins, so we won't add it up to our final summation and we can disregard all probabilities where the Pyroball misses. Now, suppose Pyroball hits and gets a critical hit. This would lead to Cinderace winning. The odds of this are 0.9, the chance of hitting, multiplied by 0.0417, the odds of a critical hit. That gives us 0.0375, or 3.75%. Now let's suppose Cinderace hits, doesn't get a critical hit, but does get the 62.5% roll. This is 0.9 multiplied by 1 minus 0.0417 for not getting a critical hit, multiplied by 0.625. This gives us 0.539, or 53.9%. Now let's suppose Cinderace hits, doesn't get a critical hit, and doesn't get the 62.5% roll, but it does burn, and the Great Tusk doesn't get a critical hit on Headlong Rush. This would also lead to a win. The odds of this happening are 0.9 times 1 minus 0.0417 times 1 minus 0.625 times 0.1 times 1 minus 0.0417. That gives us 0.031, or a 3.1% chance. And those are all the ways that Cinderace can win. It can hit and get the roll, hit and get the crit, or hit and not get the roll or crit, but burn the Tusk and then not get crit by Headlong Rush. So, if we add up all of these probabilities, we get the odds of Cinderace winning, which is 60.76%. So in reality, although the calc would lead you to believe that your odds are 62.5%, they're actually slightly lower. Aren't you glad you spent all that time calculating? If you want to challenge yourself, try calculating the probability that Great Tusk wins. If you do it correctly, you should be able to add it to the odds of Cinderace winning and get exactly 1, which represents 100%. This makes sense, as there is a 100% chance that one of the Pokemon is going to win. No matter the odds, your play here is always to click Pyroball anyway. I chose this example not for its usefulness in application, but for its level of complexity. Still, understanding these concepts will go a long way to improving your gameplay. This last example is far more complicated than you'll realistically be able to do in a game, but being able to do quick, simple probability calculations in your head is a big deal in a game with as much RNG as Pokemon. And doing larger, more complicated calculations makes the simpler calculations easier and faster. I offer tutoring sessions for those looking to improve their competitive Pokemon skills, and I've had many clients make suboptimal plays because they misunderstood or didn't consider probability. Managing odds and maximizing your chances to win may make a big difference in your level of play. If you enjoyed this video or you learned something, please consider subscribing and liking the video. Let me know in the comments if something was unclear, you didn't understand something, or you have any other questions about probability in Pokemon. Have a great day, and I'll see you next time.